The cabin roof held 23,000 pounds of snow at a 60-degree angle, while every other structure in the valley collapsed under half that weight. Inside, Marcus Hendry and Duncan MacLeod had been sealed in darkness for 14 days, breathing air heated through an underground channel that should have been impossible to build with frontier tools. Outside, the temperature had reached -77 degrees Celsius, cold enough to freeze exposed skin in under 2 minutes. What they had built that summer, while other trappers mocked them for wasting trapping season, would be the only reason anyone in the Bitterroot Valley survived the winter of 1856. Before we dive in, let us know where you're watching from, and if you've ever experienced a winter that tested everything you thought you knew about survival. And if stories of frontier innovation keep you up at night like they do us, hit that subscribe button, because tomorrow's story involves a technique so dangerous that it was banned in 3 territories. The elk were moving wrong. Marcus Hendry had spent 11 winters in the Bitterroot Valley, and he had never seen elk descend from the high country in early October. They came down in a scattered line through the aspens on the eastern ridge, nearly 40 animals moving with purpose rather than grazing their way downslope. Marcus stood outside his cabin, watching them cross the meadow below. Something had pushed them out of the mountains a full 6 weeks before normal migration patterns would bring them down. The air smelled different too, a metallic quality that made the back of his throat tight when he breathed deeply. The sky had been pale for 3 days, not cloudy but somehow thin, as if the blue had been diluted with white. Marcus was 34 years old, a fur trapper who had come west from Pennsylvania in 1845. He had survived blizzards, grisly encounters, a bout of mountain fever that should have killed him, and the isolation that drove some men insane. He had learned to pay attention to details that seemed insignificant to others. The elk moving wrong was significant. 2 days later, a group of Salish hunters passed through the valley on their way to lower ground. They stopped at Marcus's cabin to trade dried meat for gunpowder. The oldest among them, a man named Red Otter, whom Marcus had known for 6 years, stood looking at the mountains while they conducted business. Marcus asked if the early elk movement concerned him. Red Otter was quiet for a long moment before answering. He said his grandfather had told stories about a winter when the snow buried the lodges completely, when people had to dig tunnels to move between shelters, when the cold killed fire if you did not protect it properly. His grandfather had called it the winter that buries mountains. Red Otter said the signs were the same now. Animals leaving the high country too early, the strange quality of light, the way smoke from fires did not rise properly but seemed to hang and spread. Marcus offered to let them shelter with him if the winter proved as bad as the old story suggested. Red Otter thanked him but said his people were moving to the lower valleys near the big river where winters were less severe. He suggested Marcus do the same. After the Salish left, Marcus rode to the nearest neighboring cabin, 8 miles north, where a trapper named William Croft lived with his younger brother. Marcus told them about the elk and Red Otter's warning. William laughed and said Indians always had stories about killer winters. His brother asked if Marcus was planning to abandon a full season of trapping because of animal behavior and old tales. Marcus said he was not leaving, but he was preparing for something worse than normal. William asked what preparing meant. Marcus said he did not know yet, but he was starting immediately. Marcus had seen his first collapsed cabin in the winter of 1852. He had been checking trap lines during a late February storm when he noticed smoke no longer rising from a cabin belonging to a French-Canadian trapper named David Mercier. The silence was wrong. Even in heavy snow, you could usually hear sounds from occupied cabins, the thunk of splitting wood, the scrape of a shovel, something. Marcus approached and found the entire structure compressed to half its original height. The roof had collapsed inward under accumulated snow weight, and the walls had buckled outward from the force. Davide was inside with his wife and young son. All 3 had died instantly when the ridgepole snapped and brought 4,000 pounds of snow and timber down on them while they slept. Marcus had helped dig out the bodies. The image stayed with him. That incident made him start paying attention to how cabins failed. Over the next 4 winters, he witnessed or discovered 3 more collapses in the broader region. Each time he examined the wreckage carefully, trying to understand the mechanics of failure. The pattern was consistent. Standard cabin construction used a simple ridgepole and rafter system. Two forked posts supported a central ridgepole that ran the length of the cabin. Rafters, usually just trimmed poles, leaned against the ridgepole from both sides, creating a roof with a gentle slope, typically around 30 degrees from horizontal. This design was fast to build and adequate for normal snowfall, but it had fundamental weaknesses that became catastrophic under extreme loads. The problem was mathematics. Marcus did not fully understand, but could observe in the wreckage. A cubic foot of fresh snow weighed approximately 7 pounds. Settled snow weighed more, around 20 pounds per cubic foot. Wet, compacted snow could exceed 40 pounds per cubic foot. A typical cabin roof measured roughly 20 feet by 16 feet, giving it 320 square feet of surface area. During a heavy, sustained storm, snow could accumulate to depths of 6 feet or more on a shallow-pitched roof because the angle was not steep enough for snow to slide off naturally. 6 feet of settled snow across 320 square feet meant Marcus was looking at simple multiplication, though he worked it out by thinking through the weight in sections. The total load could easily exceed 25,000 pounds, more than 12 tons resting on a roof system designed by men who understood carpentry through tradition rather than engineering. The ridgepole itself was usually a single log, perhaps 12 inches in diameter. The rafters were smaller, 6 to 8 inches, and they were not connected to each other or braced in any way that distributed weight. When the ridgepole cracked under sustained load, the entire structure folded inward simultaneously. Marcus had pulled enough bodies from collapsed cabins to know that survival was rare. The collapse happened fast, without warning, usually at night when people were sleeping and could not escape. After seeing what happened to the Mercier family, Marcus became obsessed with understanding why cabins collapsed and whether different construction could prevent it. Duncan MacLeod arrived in the Bitterroot Valley in May of 1855, and within a week, every trapper within 20 miles knew he was different. He was 41 years old, tall and thin, with hands that showed old burn scars and a formal way of speaking that marked him as educated. He had been trained as an architectural engineer in Edinburgh, had worked on municipal buildings and bridges, and had destroyed his career through a combination of gambling debts and a public argument with a city councilman that resulted in him punching the man in front of witnesses. Rather than face prosecution and complete financial ruin, Duncan had sold everything he still owned and bought passage to America. He had drifted west, working odd jobs, until he reached the frontier and decided that trapping might offer the anonymity and independence he needed. Marcus met Duncan at a trading post in late May. They were both selling pelts from the spring season. Marcus overheard Duncan discussing cabin construction with the post operator, using terms like load-bearing capacity, compression stress, and moment of inertia. Marcus introduced himself and asked if Duncan actually understood the engineering principles behind building structures. Duncan said he had designed a municipal hall in Edinburgh that was still standing and would likely stand for 200 years. Marcus asked if Duncan understood why frontier cabins collapsed under snow loads. Duncan said yes. The roof pitch was inadequate, the support structure was not properly triangulated, and there was no redundancy in the load-bearing elements. He said it was appalling construction by any reasonable standard, but understandable given that most trappers had no formal training and were building for speed rather than longevity. Marcus told Duncan about the warnings he had received, the elk behavior, red otter's stories, the strange quality of the air and light. He said he believed a catastrophic winter was coming and that standard cabin construction would kill people. Duncan listened without interrupting. When Marcus finished, Duncan asked what Marcus proposed to do about it. Marcus said he wanted to rebuild his cabin using principles that would allow it to survive extreme snow loads. Duncan asked if Marcus had money to pay for architectural services. Marcus said no, but he would split his winter provisions and share his cabin if Duncan would help him design and build a structure that would not collapse. Duncan considered this for perhaps 10 seconds before agreeing. They left the trading post together and rode back to Marcus's cabin, a journey of 2 days. During those 2 days, Duncan asked detailed questions about typical snowfall amounts, the duration of storms, temperature ranges, available timber types, and the tools Marcus owned. He was making calculations in his head, planning. When they arrived at Marcus's existing cabin, Duncan walked around it twice, examining the construction with obvious disapproval. He finally said the structure was adequate for normal winters, but would certainly fail under the conditions Marcus described. He said they needed to start completely over. Marcus asked if Duncan was certain they could build something better. Duncan said he was certain they could build something that would still be standing when everything else in the valley collapsed. Duncan spent 3 days sketching designs on pieces of bark using charcoal from the fire. He drew angles, calculated loads using a system of notches to represent numbers, and occasionally asked Marcus about specific measurements. The design that emerged was radical compared to standard frontier construction. The roof pitch would be 60 degrees from horizontal, twice as steep as normal cabins. Duncan explained that at 60 degrees, snow would shed naturally under its own weight once accumulation reached a certain depth. The steeper angle meant less surface area for snow to rest on and constant sliding that prevented the massive buildup that caused collapses. Marcus pointed out that a steeper roof meant longer rafters and more material. Duncan said yes, and it also meant they would survive. The internal structure was even more unusual. Duncan designed a system of support beams based on cathedral architecture he had studied in Scotland. Instead of a single ridgepole, they would use 3 parallel beams running the length of the cabin, each supported by vertical posts that extended from the floor to the roof structure. The beams would be connected by cross-bracing, creating a framework that distributed weight across multiple points rather than concentrating it on a single pole. Duncan called it triangulated support. He drew diagrams showing how force traveled through the structure, spreading load across the entire framework rather than stressing individual components. Marcus did not fully understand the mathematics, but he understood the principle. If one element weakened, others would compensate. The chimney design incorporated something Duncan called redundant venting. Most cabins had a single chimney opening. Duncan's design included the main chimney plus 2 smaller vent pipes that could be opened or closed using metal slides. Marcus would fabricate from scrap iron. The system allowed them to control airflow precisely. If they needed maximum heat, all vents could be opened. If they needed to seal the cabin against extreme cold, they could close secondary vents while maintaining minimal airflow through the main chimney. Duncan was particularly concerned about carbon monoxide poisoning, which he said killed more people during sealed conditions than freezing. Proper ventilation was not optional. The most innovative element was what Duncan called the external firebox. Instead of relying solely on an interior fireplace, they would build a fire chamber outside the cabin with a stone-lined channel that ran underground beneath the cabin floor. Heat from the external fire would travel through the channel, warming the floor from below, then vent through a separate pipe. This system allowed them to generate heat without consuming interior oxygen or creating dangerous smoke buildup inside. Marcus had never seen anything like it. Duncan said the principle came from Roman hypocaust systems, ancient technology that frontier Americans had apparently forgotten. Construction began in early June. Duncan insisted they could not rush. Every log had to be selected for straightness and structural integrity. Every joint had to be precisely cut. Every support post had to be perfectly vertical. Other trappers who passed by during the summer expressed confusion about why Marcus was building such an elaborate structure instead of trapping during prime season. Marcus told them he was preparing for a hard winter. Most thought he was wasting his time. The external firebox took 2 full weeks to build correctly. Duncan insisted on using flat stones for the interior lining, selecting each piece for how it fit with adjacent stones. The chamber was 3 feet wide, 4 feet long, and 2 feet deep, positioned 6 feet from the cabin's north wall. From the firebox, they dug a trench 18 inches deep that ran beneath the cabin's log foundation. The trench was 2 feet wide and lined with stones to create a channel. Inside the cabin, the channel ran the length of the floor before angling upward to exit through a dedicated vent pipe on the south wall. The entire system was designed so heat would travel underground, warm the cabin floor, and escape without ever mixing with the interior air. Duncan explained the critical importance of this design one evening while they were testing the system. If they were sealed inside during extreme conditions, burning wood in a traditional fireplace would consume oxygen and produce carbon monoxide. In a tightly sealed cabin, carbon monoxide would accumulate to lethal levels within hours. People would fall asleep and never wake up. The external firebox eliminated this danger. They could generate heat continuously without affecting interior air quality. The underground channel provided radiant floor heating, which Duncan said was more efficient than warming air directly. Warm floors heated the air above them through convection, creating comfortable temperatures with less fuel consumption. The ventilation system required equal precision. The main chimney was built with double walls, an inner stone channel surrounded by an outer layer with an air gap between them. The gap allowed cold air to be drawn down from the roof, preheated by the chimney's warmth, then fed into the cabin's interior through small openings near the floor. This created circulation without opening doors or windows. The two secondary vent pipes were smaller, just 4 inches in diameter, positioned on opposite walls near the roofline. Metal slides fashioned from scrap iron could close these vents completely or open them in increments. Duncan called it the smoke protocol, a system for managing air quality during sealed conditions. They tested everything during a cold snap in early November. The temperature dropped to -20 degrees Celsius, cold enough to make testing realistic. Marcus and Duncan sealed themselves inside, closing the door and all vents except for a minimal chimney opening. Duncan lit the external firebox and fed it steadily for 6 hours. Inside, the temperature rose to comfortable levels within 2 hours. The floor became warm enough that Marcus could walk barefoot without discomfort. The air remained clear, no smoke, no stuffiness, no symptoms of oxygen depletion. Duncan monitored everything obsessively, checking the draw on each vent, measuring the temperature at different heights, ensuring the system worked as designed. After 6 hours, they opened the door and examined the external firebox. It had consumed approximately 20 pounds of wood, far less than an interior fireplace would have required for similar heating. The stone channel showed no cracks or damage. The vent pipes drew properly. Duncan declared the test successful. Marcus asked what would happen in conditions 3 or 4 times colder than their test. Duncan said the system would work even better because the temperature differential would increase the draw through the vents. The storm began on December 22, 1856, 3 days after the winter solstice. Marcus woke before dawn to silence that felt unnatural. He opened the cabin door and found snow already falling so heavily that he could not see the tree line 50 yards away. The flakes were small and hard, driven by wind that came from the north in steady pressure. Duncan was already awake, standing at the small window, watching. He said this was the beginning. Marcus asked how he knew. Duncan said the temperature had dropped 15 degrees in the last 4 hours. The wind had not varied in direction or intensity, and the snow showed no signs of the usual fluctuation between heavy and light fall. This was a system that would settle in and stay. By midday, accumulation had reached 18 inches. Marcus went outside to check on their woodpile, which they had covered with bark sheets weighted down with stones. The wind was strong enough to make walking difficult. Visibility had decreased to perhaps 20 feet. He could hear the wind in the trees, a constant roar that spoke of sustained force rather than gusts. When he returned inside, Duncan was preparing their supplies for what he called containment protocol. They had stacked enough firewood inside the cabin to last 3 days without going outside. They had filled every container with snow to melt for water. They had prepared food that required minimal cooking. Duncan said once the storm intensified further, they would seal the cabin and not open it again until conditions improved. By evening, the accumulation had exceeded 3 feet. Marcus opened the door with difficulty because snow had drifted against it. The temperature had dropped to -30 degrees Celsius. The wind had increased to the point where snow was not falling vertically, but driving horizontally. Duncan said they needed to seal now. They closed the door and barred it with the heavy beam Marcus had installed across interior brackets. They closed the secondary vents completely and adjusted the main chimney vent to minimal opening. Duncan went outside one final time through the small auxiliary door they had built on the east wall, checked the external firebox, loaded it with wood, and returned. They sealed the auxiliary door from inside. The cabin became a closed system. The sound of the wind was terrifying, even through log walls 2 feet thick. It was not howling or whistling, but a dumbulation, a sustained pressure that seemed to come from all directions simultaneously. Snow accumulated on the roof faster than Marcus had imagined possible. He could hear it, a weight settling above them, creaking the support beams Duncan had engineered. Duncan seemed unconcerned. He sat at the table, eating dried meat, occasionally checking the vent draws with a candle flame. Marcus asked if the roof would hold. Duncan said the roof was designed for loads far exceeding what this storm could produce. Marcus asked how Duncan could be certain. Duncan said because he had calculated every beam, every angle, every stress point, the cabin would stand. Others in the valley would not. They would hear the collapses soon enough. Marcus did not want to believe him, but deep down, he knew Duncan was right. The first collapse came on the second night. Marcus was half asleep when he heard it. A sound like distant thunder, but wrong. Too sharp, too final. Duncan was awake immediately, listening. Marcus asked what it was. Duncan said a cabin had failed. The sound was unmistakable, the crack of a ridgepole breaking, followed by the crush of timber and the settling of thousands of pounds of snow. Marcus asked how far away. Duncan estimated 2 to 3 miles based on how sound traveled in these conditions. They sat in darkness, neither speaking. Marcus thought about the Croft brothers, William and his younger sibling, whose cabin was approximately that distance north. He hoped it was not them. He hoped it was an abandoned structure, but he knew better. The second collapse came 4 hours later, closer, perhaps a mile to the west. Then a third, sometime near dawn, from the southeast. Duncan kept count silently. Marcus could see him marking each collapse in his mind, calculating, mapping. The storm showed no signs of weakening. Snow continued to fall at rates Marcus had never experienced. By the morning of the third day, accumulation outside their door had reached 6 feet. Marcus knew this, because he had marked the door frame with notches at foot intervals. The mark for 6 feet was now level with the snow pressed against the door. They were being buried. Duncan spent hours checking the structural integrity of their cabin. He examined every support beam, looking for cracks or signs of stress. He checked the connections where cross-bracing met vertical posts. He measured the slight deflection in the roof beams using a string tied between 2 points. The deflection was minimal, exactly within the tolerances he had calculated. The steep pitch was working as designed. Snow accumulated to a certain depth. Then the weight caused it to slide off the roof in massive sheets. Marcus could hear it happening, a grinding sound followed by heavy impacts as tons of snow slid down and piled around the cabin's base. The sliding prevented the catastrophic buildup that was collapsing other roofs. Duncan's 60-degree angle was the difference between survival and death. On the fourth day, they heard voices. Distant, desperate shouting from somewhere to the east. Someone was outside in the storm, probably trying to dig out from a partial collapse or seeking shelter after their cabin failed. Marcus moved toward the door. Duncan stopped him. He said opening the door now would let in deadly cold and snow that had drifted to above the door frame. They would not be able to reseal properly. The person outside was already dead, whether they knew it yet or not. Nobody could survive exposure in these conditions for more than minutes. Marcus argued they had to try. Duncan said trying would kill all of them. The mathematics were simple. They could not save someone outside without compromising their own survival. Marcus stood at the door, listening to the shouting fade and eventually stop. He had never felt more helpless. Duncan said nothing, but Marcus saw the engineer's jaw tight, his hands clenched. Neither of them slept that night. Managing heat became a precise science as the storm entered its second week. Duncan maintained the external firebox on a strict schedule, going out through the auxiliary door every 6 hours to add wood and clear snow from the vent pipes. Each trip outside lasted less than 3 minutes. He had fashioned a face covering from layered cloth that protected his nose and mouth from air so cold it could freeze lung tissue. Marcus timed each excursion, watching through the gun port they had built into the wall. Duncan would emerge from the auxiliary door, move quickly to the firebox, work with efficient movements, then return. Snow had accumulated around the cabin to such depths that Duncan had to dig a trench each time to reach the firebox chamber. The trench would fill again within hours. The underground heat channel worked better than either of them had anticipated. The stone-lined passage retained heat for hours after the external fire burned down. The cabin floor maintained a temperature warm enough that Marcus could place his bare hand on it comfortably, even when the exterior temperature dropped to levels that seemed impossible. On the 8th day, during one of Duncan's excursions to check the external thermometer he had mounted on a post, the mercury had frozen solid in the tube. Mercury froze at -39 degrees Celsius. The actual temperature had to be significantly lower. Duncan came back inside, his face covering stiff with frozen condensation from his breath, and said he estimated the temperature had reached -77 degrees Celsius based on how quickly exposed metal caused pain, even through gloves, and how the air felt like inhaling glass. Water management required constant attention. They melted snow in metal pots placed on the warm floor near where the heat channel ran beneath. The process was slow but reliable. Duncan had calculated their water needs precisely. 2 men required approximately 1 gallon of water per day for drinking and minimal washing. Melting snow produced roughly 1/10 the volume of water compared to the snow's initial volume. They needed to melt 10 gallons of snow daily. The pots ran continuously, refilled whenever they emptied. The system worked, but it consumed time and required vigilance. Letting the pots run dry could damage them and compromise their water supply. Food was simpler. They ate dried meat, hardtack, and preserved vegetables Marcus had traded for during the summer. Duncan had insisted on stockpiling enough food for 30 days of sealed conditions. Marcus had thought 30 days was excessive. Now, on day 9, with no signs of the storm weakening, 30 days seemed barely adequate. They ate sparingly, not from immediate shortage, but from the understanding that they did not know how long this would continue. Duncan maintained detailed records on bark sheets, marking each day, noting temperature when possible, recording snow depth estimates based on door markers, and tracking their supply consumption. His engineering mind could not function without data. The cabin held. The support beams Duncan had designed showed no signs of failure. The triangulated structure distributed the massive snow load across multiple points exactly as intended. The roof's steep pitch continued shedding snow in periodic avalanches that Marcus could hear even through the storm's constant roar. Other cabins had become tombs. Theirs had become a fortress. The storm broke on the morning of the 14th day. Marcus woke to silence that felt alien after 2 weeks of constant wind. Duncan was already at the window, looking out through the small opening. He said the sky was clear. Marcus joined him and saw blue for the first time in 14 days, pale and cold but unmistakably clear. The temperature was still brutal. Duncan estimated -40 degrees Celsius, but the wind had stopped and snow was no longer falling. Duncan said they could unseal the cabin, but should wait until midday when the sun would provide maximum warmth for the brief time they would have the door open. At noon, they removed the beam, barring the main door, and pushed. The door would not move. Snow had drifted and compacted against it, creating a wall. They shifted to the auxiliary door on the east wall, which opened inward. It swung free, and Marcus stepped out into a world transformed into something unrecognizable. Snow depth varied wildly based on drifting patterns. In some areas, it reached above Marcus's waist. Near the cabin, where the steep roof had shed its load repeatedly, snow was piled to the roofline, creating massive berms. The landscape had no familiar reference points. Trees were buried to their middle branches. The creek was invisible beneath a white surface. The sky was painfully bright, sunlight reflecting off endless snow. Duncan emerged with snowshoes they had constructed during the sealed days, anticipating this moment. They strapped them on and began moving through the valley, checking on other cabins. The first structure they reached was Thomas Garrett's cabin, half a mile south. The roof had collapsed completely, compressed down until the walls buckled outward. They dug through snow at the door and found Thomas inside, dead, crushed when the ridgepole snapped. The second cabin belonged to a trapper named Michael Stone. Similar collapse, similar outcome. Michael and his partner both dead. They continued methodically, checking each known structure within 5 miles. By the end of the 3rd day of searching, the count was devastating. 11 cabins had collapsed completely. 23 people were dead. Most had died instantly when roofs failed. 3 had died from smoke inhalation, apparently trying to heat inadequately sealed cabins with fires that consumed their oxygen. 2 had died from exposure, found frozen between collapsed structures, apparently trying to reach neighbors for help. The Croft brothers were among the dead. Their cabin had failed on the second night, the first collapse Marcus and Duncan had heard. William and his brother had been buried under timber and snow while they slept. 4 people had survived, 3 men and 1 woman who had been at various cabins visiting when the storm intensified. All 4 had made their way to Marcus and Duncan's cabin during the storm's early days, before the worst cold set in. They had crowded into the structure, rationing supplies that Duncan had stockpiled. The cabin's design had saved 6 lives total. Duncan looked at the collapsed structures with an expression Marcus could not read. Finally, the engineer said they needed to bury the dead before scavengers found them. Marcus agreed. They spent the next week digging graves in frozen ground. The survivors left the Bitterroot Valley that spring. Of the 4 who had sheltered in Marcus and Duncan's cabin, 3 decided trapping was not worth the risk and returned east. The 4th, a young man named Peter Ross, stayed in the territory but moved to a lower elevation where winters were less severe. Marcus and Duncan remained through the spring trapping season, working the lines that now had no competition. The valley felt haunted. Empty cabins stood as monuments to failed engineering and dead men. Marcus and Duncan rarely spoke about the winter, but it was present in everything they did. Word of what happened spread through the frontier trapping network by summer. Stories traveled with traders through trading posts, carried by men who had seen the collapsed cabins and heard accounts of the storm. The detail that caught attention was not the storm's severity, but the fact that one cabin had survived completely intact while every other structure failed. Trappers began asking questions. What had Marcus and Duncan done differently? How had they built their cabin? Could the techniques be replicated? Marcus and Duncan found themselves explaining the engineering principles to men who had never considered that cabin construction involved actual science. The steep roof pitch became the most widely adopted innovation. 60 degrees from horizontal was easy to understand and implement. It required more material and more labor, but it required no specialized knowledge. Trappers throughout the Rocky Mountain region began building steeper roofs. The triangulated internal support structure was more complex, and fewer people implemented it fully, but even partial adoption of the principle, adding extra support beams and cross-bracing, improved structural integrity significantly. The external firebox system was the least adopted innovation because it required the most work and technical understanding, but trading posts and permanent settlements began incorporating variations of the design. Duncan left the mountains in 1858. He returned to Scotland with money saved from 2 profitable trapping seasons and detailed drawings of the cabin system he had engineered. He found work with a construction firm in Inverness that specialized in highland buildings. The techniques he had developed for extreme conditions in Montana found applications in Scottish mountain construction. Buildings designed using Duncan's principles of steep pitch, triangulated support, and redundant systems proved exceptionally durable in harsh highland weather. Duncan never became wealthy or famous, but he rebuilt his reputation as a competent engineer. He died in 1879, respected in his field. Marcus remained in the territory. He married a Salish woman named Rain Singing in 1860 and built a ranch near Missoula. They raised 4 children. Marcus taught his sons to build structures that would stand against anything nature offered. He never trapped again after 1858. He did not need to. The winter of 1856 had taught him that survival was not about exploiting resources, but about respecting the environment enough to prepare properly. He died in 1884, 62 years old, surrounded by family, in a house he had built with a 60-degree roof pitch and triangulated support beams. The house still stands today, weathered but solid, a testament to what one winter and careful engineering can teach about survival.